And we are live. Oh, it transitioned before I even turned around. That's gonna have to, whatever, that's gonna be the way it is. That's how we're doing today. Hello, chat. I don't think anybody's here yet, but I can stream to nobody. I've done it a million times before. Let me make sure everything's up and oriented. I can show you my screen. I can show you what I'm looking at. Let's do that. Look, I'm in a circle now. Isn't that neat? Anyway, yeah. So I've done a lot to my streaming setup yesterday, and I'm ready to stream about a new project. We'll see if I keep streaming it. I would like to. This is going to be a project that I do in Rust. I'm hoping to, in the spirit of just program something, I'm hoping to really dropkick myself through the door of working on this sort of project. This is something I've been thinking about for a while. It is a software project. I'm building a piece of software for tabletop role-playing gamers. Particularly those who, honestly, other people could use it though too, like authors like to build worlds, and it's for world building. It's specifically for map making. It's specifically for large scale map making, which is the second largest scale there is, which is planetary map making, where you could also do interplanetary map making or intergalactic map making, but I would call those similar. I have a dissatisfaction with the existing map-making softwares as it comes to planetary map-making, which is that many of them lack the features that I want, and almost all of them do not understand that planets are spheres. And so they assume that planets at best are cylinders, at worst rectangles, and so they all have pinching at the ones that assume that planets are cylinders have pinching at the poles because they don't understand that planets are round, and then the ones that assume planets are rectangles roll them into cylinders first and then pinch at the poles, so they not only have pinching at the poles, they have a seam down one edge. I'm going to show you an example of this. Okay, to be clear, this is my favorite fantasy map generator. This is a great map generator. It just has this problem, which is that it is on a rectangle. So we're generating the whole world. We're going to hit new map a couple times. Oh, we did it right off the bat. Okay. Check this out. So by generating one that both touches the top and touches the edges, we see the seam here, right? And we see the pinching at the poles. Now, there's an issue when you try to do this. It works great for standard, to be clear. The and all the stuff that they have here, like this is an incredible map maker. I've got nothing but respect for all the work that's been put into this. It just doesn't have these two features that I personally really like to have. I'll show you mine. Okay. This is planet Earth. This is a paper model of planet Earth. Sun rises in the east and sets in the west. So if you're the sun, this is how planet Earth orbits on that axis. So this is a paper model that I made from an equirectangular or stereographic image of Earth from NASA that was open source. This is awesome. I want to be able to make this for my tabletop groups of the world that they live in. I want to be able to point on a globe and be like, you're here. The person you just met is from here. You know, the big, bad, evil guys from Madagascar. You know, whatever. So that's the problem. That's the problem we're solving. Let me go back. Okay. So when you have a map like this, you want to, here, let me make it be biomes. The way they generally do this is they make all these tiny little tiles. And you want all the tiles to be kind of equally spread out, but you know, you don't want them to be squares because then it doesn't look as cool. You want them to be kind of mishmashed, but so that's a Voronoi tessellation. It can be a Voronoi tessellation. Voronoi often is done as an offset square grid, but like a square grid where each square center is randomly offset a little bit, and so you get tiles spread out that way. I'm inclined to scatter points across the map randomly and have them do kind of a weighted self-distribution where they kind of shuffle and squeeze and they just push away from each other until they're all kind of equally spread out that way. And that's actually about as easy to do on a rectangle in terms of the equations you have to come up with as it is to do on a sphere. If you pick a globe, if you planned for these to be on the globe in the first place, these points could be, see, like this tile here, each of these tiles is supposed to be kind of like one of these, right? Actually, that might not be true, but definitely this tile is supposed to be shaped more like this tile. If you do it planning on being on the globe in the first place, you'll have fewer of them up here, so they don't have to be squashed as much. And so if you do your coordinates on the globe in the first place, now it does mean that when you switch back to a standard map, you're going to get stretching towards the poles, but to me that's preferable. If you do a full globe map, you should have stretching towards the poles. That's just sensible to me. And then I want my mapping software to be able to make subsets of the map that are more rectangular, and like if you make a rectangular portion of this section of the map, or of this section of the map, anywhere you zoom in, it should show up properly rectangular, you know? Okay. And then I said to myself, why am I doing it on a sphere? When people make fantasy worlds, they don't always want them on a sphere. And in particular, if I do it on a sphere, it's going to be harder to reprogram it to then work on arbitrary shapes. I would rather program it to work on arbitrary shapes in the first place and not have to reprogram it later. So that's where we're at. That's where we're at. That leaves us with me trying to import a user-generated mesh at runtime, check it for problems, and then use it for world generation. And I want to start with continents. I want to generate continents, to generate the land masses and ocean masses, and then use that to generate where the mountains are, where the terrain is, other than the mountains, where the rivers are, work from there, right? And I'd love, we're starting to get into stretch goals. I would love for the user to be able to We'll get to that some other day. Today, I want to hit the ground running with the fyrox engine, which is a Rust game engine that Bevy is the Rust game engine that I hear the most talked about. But if you go on the Bevy website, it says immediately, do not use this for a project that you're actually working on, that you want to keep working on, because Bevy does breaking changes still. They are still in their pre 1.0 release, whereas this is in its 1.0 as of last week. I had no idea that was so recent. Gonna be honest, when I decided to use fyrox, that was more than a week ago. That's really funny. How did that come to pass? Anyway, fyrox is in there 1.0. Fyrox has, I will show you. Here. fyrox has this. This is the fyrox tool that we're looking at here. This is fyrox. Well, it has all of this. I feel like this means that it has GPU support. I think I looked at it and it does. Hot reloading is wild and something that I'm sure I will work into my workflow, but is not part of my workflow yet. Multi-platform is huge. I would love to put this thing on my website if it's compact enough to go on my website. Because if job people want me, based on me having built an awesome thing, they're welcome to. I love documentation. There's some of this I'm not anticipating needing, but I'm not sure where I'm going to stop with this project. This may feature creep itself into a very deep, but compelling hole. Point is, it's got this graphic user interface in addition to having like a Rust backend that I can do any custom stuff with, and I'm excited about building it in Rust, mostly because I like Rust and I'm excited to build something in it, but also because what I'm going to do will likely be computationally intensive. So I've been reading a bit of the fyrox book. I'm going to keep reading that on this stream. Hopefully do at least a little programming on this stream to try to import a mesh from the user. Let's make that mesh real quick. Here's what I want. I want a sculpting template, and so if I switch to mesh view, this is a let's do okay. You can see this is a super subdivided cube. This is what I'm going to start with for my sphere. Okay. So if I add the subdivision modifier to this, deform probably. There we yeah. So if I keep subdividing this, you eventually get the same anyway, I think you can see what I'm talking about. The you're ending up with this shape with this wireframe. If I apply that modifier, you'll start to see that. That's what you're getting. You're getting a subdivided cube. So we're gonna export this mesh. I'm calling this project Glorbe because it's for building globes. Oh, did I say save as? I didn't want save as. I wanted. I want to export an OBJ, I think. I could do STL. So at a base level, the subdivided cube should be able to import and display by the end of today. I don't want to import it directly into fyrox as the developer. Like the developer of a game will always be importing models, and that's a super standard feature. I need the player of the game to be able to import their own custom model. That's what I need to work. Okay, selection only. I'm not worried about most of this. I don't need the materials, but I'm not going to delete them. I'm just going to leave them in. Great. Now we have our OBJ. Here's fyrox. And I don't know a thing about what happens next, so yeah, bear with me. Okay. So far, a scene in fyrox sounds a little bit like a node in Godot. A scene in fyrox plays the role of a prefab. Maybe I'm wrong. Maybe I'm wrong. Game scene and user interface. Okay. Nodes and scene graph. A scene is made of one or more nodes. A scene node contains a specific set of properties as well as a number of scripts which are responsible for custom game logic. Works for me. Typical structure of a scene node can be represented by, okay, there's a base. It's got a transform and some children. Okay, we can compose on base. A mesh node is a base node, plus a mesh would have a list of surfaces, a material, etc. Okay, great. The hierarchy depth is unlimited. Okay, my scene tree can have a lot of depth. Each of those can have a base light node. Okay. There's a point light. It's got properties. It's got a base light. I don't really know what a base light node is, but it can have a base itself. Okay, whatever. Okay, great. I will say that fyrox says that it is prime for use with object-oriented programming, And it also has this to say about the entity component system model of setting stuff up. It suggests that the performance that you gain from it is more important if you have tens or hundreds of thousands of objects to manage. I don't know. Meshes are complicated, and I'm going to be putting all sorts of stuff on mine. I think I might be doing this. I think I might have to do ECS, but it says they argue why ECS is unnecessary, but it does say somewhere that if you want to use ECS, you can hack in your own. I don't know where it said that. There's no built-in ECS framework, but there's plenty of them in the Rust ecosystem. So, yeah, you can manually synchronize ECS entities. So, we might be doing that. I think we are doing that. I've been looking into ECS. Here's HECS. This is one of the ones somebody on Reddit recommended. Maybe it wasn't the one on Reddit. Maybe... yeah, this person, this is published as of December of last year, so I feel pretty good about it. These are the three they said. Somebody said Legion hasn't been updated in a while. I don't know if that's up to date. Let me find out. Latest update is in 2021. Legion is off the table. Let's do Shipyard. Okay. One second. Let me figure out why my light's not on. Alright. Shipyard last updated January 1st. Not bad. Not bad. What version are we on? 0.11. What's HCS? Also 0.11. Why is nobody committing to a version 1.0? Tell me the state of your project. Tell me the state of your project. Tell me the health of your project. Okay. Oh, I will say I considered using, so Bevy has the Bevy ECS. Let me see if they link to it easily. Okay, Bevy. I want a link to the crate. Here we go. Here's the thing about Bevy ECS. It is by itself an entity component system engine or framework, whatever. It's weird to call it entity component system because entity component is not the type of system it is. It's supposed to be entities, components, and systems. Yeah, it says that. Look, broken up into entities, component, and systems. It's the entity component system paradigm. It is an entity component system library. They're saying it is an entity component system, which is a weird phrasing. Okay. Anyway, somebody said that Bevy ECS is a little bit of a heavy library because it's specifically also supposed to carry the weight of the Bevy gain engine. It's not just an ECS library. It's, oh look, that's on 0.18.2 or 0.18.1, but as well. It's also not in 0.1 or 1.0. Now that's compelling. I might have to look into that. If other Rust ECS lifetime implementations are doing a bunch of complex stuff, I might not want to be doing them. I'll accept like one or maybe two complex things, but anyway, this Reddit post was saying that Bevy, no, not that Reddit post, a different Reddit post. I don't know. Bevy doesn't do as well on the benchmarks because it's got all this extra stuff happening to support the Bevy engine. But now I suspect that perhaps it is extra stuff to avoid doing complex lifetimes, trades, builder patterns, or macros. It's not that much worse than the other ones they said, but you do see it on the benchmarks. So just worth being aware of. If there's a bare bones one, and I can make bare bones work, which I feel seems possible because I'm not making a massively multiplayer game. I'm making a fully local. It's just got to do a lot of computation. So I just need it structured as an ECS framework. It doesn't need to be sexy. So Shipyard. Okay, we did not write off Shipyard. I know very little about Shipyard. I love this. They're giving an example of... so the basic thing of entity component systems is all of your entities end up in a list, and then you run a particular procedure on all the entities in the list. And you'll have the entities pre-sorted. Each entity isn't composed of all of its features. Each entity is composed of like each of its components that can be split apart end up in different lists in memory. You'll have one list of all the entities that are in acid. That's what I'm getting. See, this isn't what I heard. All of your entities are going to end up near each other in memory. If you make sure that your list is exclusively a list of the things that are going to be needed next to each other. So in the context of in acid, you only need the health. Which is to say, to determine whether it's in acid, in this example, you need the position, because they're using the position within the world to decide whether a particular entity is in acid. But once you know whether it's in acid, you only need the health. So if you have a list of specifically entities that are in acid, you could have a list just of the parts that handle the health. And iterate over those and, subtract one for everybody that's in acid. So, and that would be fast because those would all be right next to each other in memory, and you're iterating over them without a switch statement. Here, this filter that's iterating but filtering out based on whether they're in acid. This is going to have an if statement on each of the components. I feel like that's not the most optimized version of this, but you do what you got to do. In my case, I've been looking at. That's nice. Don't do that. I've been looking at this fast, exact, and appropriate fast, exact, and approximate geodesics on meshes, which develops on previous research out of 2005. I think this came out in 2015. No, this came out in 2005. The previous work was maybe in 1985 or something. (1987) was the previous work. So somebody in 1987 proved that if you have an arbitrary mesh and you want to figure out the distance between the point on the tip of the nose and some other point on the surface, it's a really inefficient algorithm. These people came up with something that is better. And specifically, often when people prove that there's a better way to do something, they're proving that there's a better way to do it if you redefine the problem slightly. In this case, the problem that they've defined is picking a point on an arbitrary mesh. And by arbitrary mesh, I do mean kind of like a whole and complete surface. There's no holes. There's no like rips, tears, pinches, whatever. Maybe pinches are fine. But they pick a point on it, and it's just a normal surface that you can do math on. And going across that surface, they figure out from every point what's the length of the shortest path to that point. And a geodesic is drawing a line to that point over the surface. And they've figured out this thing with what they're calling windows, where you can kind of like shine this beam of light, and anywhere any of these windows and the points within this window can all have their, this is if you flatten out all of the consecutive faces, anything in this window can have its distance back to the original point calculated pretty trivially. And then you get problems where when this is the original point you're measuring everybody to, and then you have, you shine windows directly. If you, this is the unflattened image. If you flatten it out, these are two copies of, they've cut a seam here and made two copies of the original point to demonstrate that there's overlapping windows here. So this is all one window from the left side. This is all one window from the right side. And they've got overlapping windows here. So you can have either overlapping windows or you can have gaps. And in those cases, they adapt. They in the case of gaps, they wrap around the corner starting from the first point that they have there. In the case of here, they find the point somewhere along this line where the distance going this way is equal to the distance coming around the other way. And they slice it at that point, and they have one window that's joined going this way and the other window that's joined going this way. So they slice this somewhere and just make it be a total of two windows based on whichever spot is shorter. That's all just out of interest, but really the upshot is that this is all very difficult and not necessary for... This would have been necessary for the way that I was doing the code before. I have a previous attempt at this. I don't know if I could find it right away. I bet, oops. I bet it's in Python Madness. Nope, it's not that. Yes, here we go. Okay. I wish this had visuals with it. I haven't taken the time to figure out how to do visuals in Jupyter Notebook, but this is essentially trying to evenly scatter points on the surface of a sphere. So I generate any number of points uniformly across the surface of the sphere. This is actually, that's not true. They're uniformly spread in a 1 by 1 by 1 cube. And then I do what I was describing much earlier when I had Asgard's map open. I described that I wanted points to be spread evenly across of a surface. That's actually what I'm doing here in this push. I'm using the distance function defined here, and I've got this comment about distance. So on a sphere, the arc length between points, otherwise known in a more complex mesh as the geodesic, between the 2 points, the length of the geodesic between 2 points on a sphere will always be the shortest arc between the 2 points. And proportional is not the right word, but if you had a function comparing the arc length between 2 points on the surface of a sphere and the distance in 3D space, the Pythagorean distance, it would be strictly increasing. And so the effect is that if you calculate Pythagorean distance, close points get smaller numbers than far points, and that's all I really need for this. Because what you're doing when you push the points apart, you want every point to push away from every other point until they end up kind of spread apart. For each point, look at every other point, find out 1 over the distance squared, which without being too critical and, This is all of this code is very not hand wavy, but just like if it works, it works kind of. This is the opposite of gravity, basically. The gravity, you take the distance squared and 1 over the distance squared. Something, 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 1 over the distance squared means that the things that are farther away don't push on you as much or pull on you as much. In this case, we're just doing the opposite of gravity, where it's the same strength, but instead of things pulling each other closer, they are pushing each other away. And we don't even keep them on the surfaces of the sphere. They actually push each other off of the surface of the sphere a little bit, but like adjusted to be slightly differently arranged to be, if there are a lot of them clustered over here, they're going to be kind of pushing each other out this way. And then, so for each point, look at every other point and use every other point to push it away a little bit. Write down the new copy of where it is, and then go through the rest of the points without touching the new copies. And then at the end, take all the new copies and map them back onto the sphere. So if the points all start clustered up on the surface of the sphere up here, they start to spread out, and over a bunch of iterations, they're getting popped out and then pushed back on the sphere, popped out and then pushed back on the sphere until they're evenly spread across the surface of the sphere. And you can measure the movement. You can measure how much movement there was in one iteration of all the points. And so you set distance moved is the movement between the second set of points and the first set of points that you started with. And you can tell when they've settled because the amount of movements between the two iterations gets really small. And so I could say, so I have this is 10 random points. If I do that, wait, why is points B push of points B? Wait, sorry. Points B is push points B, so that's great. This only works as long as they start as the same. Oh, they do start as the same. They're the same here, and then they're the same here. So distance moved is now points B from points A. Okay. Points A is points B. Points B equals push. Honestly, this could be A, and it wouldn't make a difference. And it would make more sense. Movement from B to A. I wonder if I even noticed that that's the way that was working, or if that was literally just a typo that happened to not mess anything up. We can also just do this. We don't need. I think that's still gonna work. Am I wrong? Points A is points at 10. But I did define it. It's defined right up here. Okay, we're just gonna go through. Bam, 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 bam. Sure. That's great. And then this is a final successful. Supposing it completes eventually. So it did 756 iterations, and then these are the points on the sphere it came up with. This is 9.98 times 10 to the negative 6. That's how much it moved that time. I wonder if there's a really easy way to plot this. Okay. Wait, I don't want to copy cell. I just want to copy this much. Okay. We're gonna CSV. Okay, we gotta. I think it's this one. I'm surprised Rainbow CSV has that many. I don't really want rainbows, but anyway. Doesn't really matter. Okay. 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 Let's see if we can just paste CSVs. Nope. Maybe we do want you. There we go. There we go. Insert chart. Nope, that was not it. Scatter. Oh no. I just want them to show me a ball. I don't even know if okay, I'm gonna try it again. Insert chart. There we go. See, why does a scatter plot have to be? Oh. Okay. We can do this. Okay, we're gonna do, we want to transpose. Okay. There's no edit menu. What are you messing with me? You're messing with me. Okay, that'll do. Okay. Okay. These are the x values. Bam. These are the y values. Bam. These are the z values. Bam. Fun fact, you suck actually. That's a browser problem. Okay. X. Y. Z. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points on the surface of a sphere. Not positioned in any way that I would call like predictable. Let's position. Well, I don't know. Doesn't matter. You see the idea. They're spread out kind of on the surface of the sphere. It's pretty cool. In fact, let's just do a bunch. Let's go back over here. Let's do 100 points on the surface of a sphere. Let's make it a fun number. Let's make it 420 points on the surface of a sphere. And let's only print it when it's done. I might have gotten that wrong at the end there. This is why we're doing this in Rust. Not that there aren't faster options than Python other than Rust. But this is also why we're doing the optimizations I was talking about. So there's a couple inefficiencies here. There's a blatant inefficiency in that there's a blatant inefficiency that each distance between 2 points is being calculated twice. We're calculating the distance from A to B, and then we're also calculating the distance from B to A, and that's gross. That's nasty. We shouldn't be doing that. But I just whipped this code together. It wasn't architected for a 420 point problem. I also could have made the stakes lower. In fact, maybe like I could make this be thousands. I really made the stakes be pretty freaking high on this. Here's what we're going to do. I wonder if I can interrupt the kernel. Great. Yeah, without screwing things over too much. Let's at least make it be thousandths, and we'll have it say oh, there's I is already an iterator. If I 1000 equals 0. Great. Let's do that. I should totally redefine this, though. This should not be this should calculate the distance between every pair of points once and then do this. It hasn't even done 1,000 of them yet. Okay, we're gonna interrupt this again. We can make this way better. I totally don't need to be doing this right now, but in fact, it's already been an hour. Maybe I should just not be doing this right now. No, we're gonna do it. We're gonna do it. Okay. Okay. Great. Okay. 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 Great. Is points an array? Points is an array. We can do better. We can do better. Here's what we're gonna do. I think I can do that. Okay. We don't have to check this anymore. Okay. In fact, I think we can do that. All right. We have a square array. We don't need the ones straight along the diagonal. The weights along the diagonal don't matter. Don't matter. Should remain none. If AI is less, okay. So if BI is greater than AI, yeah, we're good. Weights at AI. Great. Okay. We no longer need that. Let's do what we were doing earlier. And all of this can go back. Okay. Then we don't need to do the distance formula here. That's the whole gain is And we don't even need to compare point A to point B anymore. We can just compare integers, which might be faster, and I don't know, but you know, definitely is fast. Let's try that and try that. Okay. 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 Why didn't it print stuff? Oh, I gotta run this first. Well, that's weird. Let's do none. I did this wrong. Yes, I did something wrong. AI, BI, BI, AI. If AI is... We shouldn't need this. That's automatic. Okay. I guess that's fine. No, that's not. Here. Okay. After the first one, so A is the column. No, A is the first column, first row. Second column, second row, but it gained. Why is it leaving spots blank? It should not be. It should just be. This point should be blank. I guess we gotta do that. Okay. Well, how is that happening? How about we do why is it 0, 0 first? Oh, I'm so freaking dumb. Okay. Great. We don't need you. We need you. We need you. Hopefully we don't. Let's check you. Oh, I should have left these on. Let's do you, don't do you. Okay. We got the first row in the second row. We got first 2 rows in the second row is no diagonal. We got, and down at the end, we got no diagonal. And we get a result. Okay. I don't know how much faster this will be, but let's find out. Let's do it mod 100. Got faster. Okay. Wow. Wow. Maybe I'm not understanding. Did I interrupt? Yeah, we interrupted. We're going to run it. Yeah, okay, so the problem is not the printing. I've never seen this message before. Okay, well, let's do a number much smaller than 420. It hasn't even done 100. Okay. Oh my gosh, I didn't want it to do that. I didn't want it to do that. Oh gosh, oh gosh, oh gosh, oh gosh, don't do that. No, you go. And that's all. Okay, gosh. Oh gosh. Okay, do it again. Okay, you worked that time. Now let's do 420 again just to see if that was the issue. Okay, it's done 100. It is at 0.1. Let's see how quick it's decreasing. It's at 0.04. That's promising. We want it at 0.01. It just jumped up. Let's go to the bottom for next time it jumps up. Just jumped up. It's at 0.025. It's the total movement between points. Honestly, that's probably pretty good. We could stop it there. Total movement between points. I should be dividing by the number of points. Yeah, this should be totally divided by... I can't believe I didn't do that already. But we got 0.01. Not a lot of movement in 0.01. Okay. Where are we looking? Where are we looking? 1,000. 0.008. We're converging close enough for me. This is really exciting. 0.008 to 0.7 is not great. Okay. 0.01. That's strange. I've never seen it go up before. Okay. I can't think of why it would go up. 0.008. At least it's working its way back down. I've never run it on this many numbers. 0.005, that's the lowest we've seen yet. Okay, we're looking for 0.001, and then it'll stop. 0.004, that's still smaller. It's really weird that it went up. That's really weird. That's really weird. 0.00. Oh, I guess I can see a situation where it would go up. 0.004. 1. 0.0043. Okay. 0.005. Okay, not the best. I'm really excited. This is really cool. 0.0068. So what happens is as the points are moving around, you can have them start to converge and then them starting to shift out of each other's way, but then one will get out of the way enough that like a whole line of them realize that they can shift over. And so we are actually seeing it optimize this arrangement. It's not going back up because it didn't have anything to do. It's going back up because it did have something to do to rearrange it a little bit. And those rearrangements are going to be gradual improvements. 0.00. 0.00327. 0.00237. This is really exciting, folks. It's really exciting stuff. It might not seem that way. You might not think that this is riveting content. 0.0206. We're getting freaking somewhere. We are optimizing the crap out of our 420-sided die here. That's what this really is. If you arrange 420 points on the surface of a sphere evenly spaced out, you get a 420-sided die when you sand off each of those points. 0.0016, we might get it in the next iteration. This might be it. Okay. 001299. One, two, four. Yeah. Okay. 127. This is not a good sign. It is not converging fast enough. But it's already it's way more precise already than it needs to be, but I really like it, so we're going to keep going. I'm sorry if this stream is not what you want it to be. It is exactly what I want it to be right now, in this moment. Oh, 024. Oh, 0466. See, we're still finding movement in there. We're finding things that are adjusting. It's still finding stuff. I was hoping it wasn't. 0453. It's still adjusting stuff. It's still adjusting stuff. 35. Okay, back down. Riveting stuff. Okay, this is 00333. Yeah. Distance moved is movement divided by length. Okay, we're going to try again. What? Okay. Did it just, that's just it. That's just it. It immediately. I don't really have a scale for how precise it should be here. Okay, after 100 goes, it is 0002. 0002. Let's put the one. We'll do two of those. We'll interrupt the kernel. We'll run this. We'll just have it do probably 1 decimal point better than it started. You know what? You know what? Here's what we're going to do. 0002 is pretty freaking good. We're going to make this be 10 so we get to watch it move around a bit. And we're going to go. Now, it just keeps going. It's going so fast. Because I told it to go faster. To do less. I told it to do less. Great. Great. Here's our result. this. We're going to put this in VS Codium. Great. We're going to delete that. We're going to delete that. Delete that and that. Do that. Great. And we're going to say comma space gets replaced, comma. Great. We're going to do that. Do that. We got 420 rows. Now, we want to transpose, do that. See, I knew it. I knew it. Let's do that. Okay. Okay, home and here, X data. Nope, U. Home and Y data. Home and Z data. Heck yeah. Heck yeah. Oh, I knew it was going to be great. I knew it was going to do exactly what I wanted it to frickin' do. Okay. What a pleasing result. Okay, here's the thing. Here's the thing about this strategy is it only works for spheres. Here's the thing. What I was doing is getting them all to push a little bit away from each other, which for each of them should push them just a little bit out off of the surface of the sphere. A little bit out. That's if they're all evenly spread out, each of them should just go a little bit directly out from the surface of the sphere. But if there's like slightly more density on one side than the other, then the ones that see that density on one side of them and not the other will be pushed out of the surface of the sphere, but up to that side a little bit. So they get pushed away from the denser parts and they end up slowly, grouping up around the up here. So, oh, they're so beautiful. Look at how evenly spaced they are. That's incredible. That's incredible. My own personal 420-sided object. Worth it. All right. That's enough of that. Oh, look, now it's a golf ball. Oh, boy. I'm pretty chuffed. I'm chuffed. I'm chuffed. I'm chuffed. They call me chuffed. Okay. What do I want to do? I want to close Firefox, that's for sure. Okay, I want to close you. Don't need that. Don't need that. Don't need that. Okay. Do I need this? See, this isn't even good reference because it's not the thing I'm trying to do. So this all was based on this working on a sphere, which works on pushing it off the surface of the sphere and then it dropping back down. That doesn't work if it's a concave surface. I feel like that doesn't work if the curvature isn't uniform, which is only the case on a sphere. So I'm just going to have to go ahead and do the actual work of calculating geodesics on the surface of the objects. And the other thing I'm going to do, since geodesics, as we saw, here. Okay, they say that this is pessimistic. They show a slightly better version, but their better version is based on calculating one point to every other point. I still have to do that to all the other points. So they do n log n, but I've got to do it for every point to every other point. So it's still n squared log n. Or something like n factorial n log n. I don't know. No, that's not fair at all. It's not that. It's not that. It's not n factorial. That's totally wrong. That's totally wrong. That's totally wrong. I did that math wrong. Something like n squared log n. I don't have to do it on every other point. If you think about all the way those points were all clustering, I can do two things. One is I can make sure that they start pretty evenly spaced across the surface. And the other thing I can do is have them only push against other points locally. No, that doesn't work. That doesn't work. I'm gonna have to workshop this. I'm gonna have to workshop this. I'm gonna have to workshop this. Okay, I'm gonna talk out loud because this is a stream and that's what you're supposed to do. I'm picturing points moving around on a surface. I cheated in the sphere version and got them to push away from each other, not remaining on the surface, but pushing off of the surface and dropping back down on, which is a good approximation for a sphere, but doesn't work for arbitrary surfaces, arbitrary within the parameters that I need. Like, you could make a planet out of it. So it's a solid object, similar to the whatever. Not important. Focus up. Calculating points to push across each other, to push each other and remain on the surface. I could have them only push on nearby points. I could have it do one shot where it clusters all the points into the groups that are immediately adjacent to each other. Like all the points that are on a given face are grouped together, and you know which faces are adjacent to which other faces, so you can kind of like find the nearby points that way. But if they all push against each other, the density could be inconsistent across the object is the problem. If it's like slightly more dense on a whole part of an object over here, and I'm only calculating stuff locally, then it could think that it's pretty evenly spread out, and it could just be a gradual enough change to an unevenly spread out place that it's pretty spread out over here and pretty clumped over here. And that would be unfortunate. It would also be avoidable if I placed points on the surface proportional to how big the triangle is that I'm placing it on. Every surface is built up of triangles in this context. If I took the size of the triangle and had that be its priority in getting a thing placed on it, I think that because what that would do is that would give across the whole surface, many points might be clustered closer or farther together, but any given region of the surface will have the same average number of points compared to its surface area. I think that's viable. I think that's viable. In fact, it doesn't even have to be random. It could be literally proportional. I could skip a bunch of randomness. Have the only randomness be where it's where the certain points are placed on the triangle. But yeah, I'm gonna have to workshop it. I'm gonna have a bunch of tiles moving around these triangles, though. I should definitely be doing the entity component system. This thing about hundreds of thousands. I think that's the region I'm in. I think that's the region. Because a shape like this has thousands of triangles depending on how I'm imagining somebody playing a fantasy world where this is the shape of the planet and you zoom in and you make maps on points on the surface. I'll have a maximum curvature so that you can't have like sharp edges, but okay. I do think this is doable. Let me write down real quick everything that I thought is doable. Okay. 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 Don't calculate every geodesic to every point. Only calculate distances to nearby points. Points should be in a clustered data structure by location on these sides. Triangle or clump of triangles. Because points now only push gradient would be able to survive the maximum movement per iteration test. Therefore, distribute points per region proportional to the surface area of the region. Across the object. There may be local clusters that will be redistributed. No global scale. Differences in density. This is great. This seems extremely doable all of a sudden. And I need to download fyrox. Or I need to be able to load the model in fyrox. Okay. I really like these ideas. I'm really glad I wrote them down. They are good ideas that I will forget immediately, and now I have them forever. So, things I don't need anymore. Jupyter Notebook. That's not Jupyter Notebook. That's Jupyter Notebook. Bam, bam. Do I need this? This is Shipyard. We're keeping you for reference. MPSC. This is a cool thing that you might need when you're multi-threading in fyrox. Gonna leave that open. Specs. Last updated 2023. You're out, son. Oh, there's other thing. Okay, this is Shipyard. Where's Hex? Am I writing off Bevy ECS? Okay. Shipyard, Bevy ECS, and Hex are all... Why not easy? Oh. Yeah, I'll read everything everybody has to say. Leader, you're on the table. You're on the table. I didn't need that. Nope. There we go. Okay, these 5 tabs are all about deciding what my ECS is. Okay. Bam. Bam. Shipyard. Bam. Great. We'll close this too. Great. Don't need you anymore. Fyrox book, we need you. We can close that. Close that. Yeah, we'll keep you. Do we need you? Do I need you? Let's keep you around. Let's keep you around. Great. Oh, these there we go. Okay. Okay. Finally, we're gonna, okay. Goal. Make a fyrox program that you can run it. Open a mesh. Look at and orbit the mesh. That's my goal. Okay, we're gonna write that down. Great. I feel like I can do that. I have no reason to believe that. Okay, I'm supposed to read chapters 1 through 3 to get an idea of how to work this. Plugins. Container for global game data and logic. Its main usage is to provide scripts with some data and to manage global game state. Game can have multiple plugins, but usually only one acts as an entry point. Oh. Okay. I don't really know about globals in Rust. I don't know how that works, but I'm sure it will tell me. Separate piece of data in logic that can be attached to scene nodes. This is the primary way of adding custom game logic. Okay, scenes are a type of node. A scene is made of one or more nodes. Every scene must have at least one root node to which everything else is attached. Okay, we're gonna just run with that. Design philosophy and goals. Blah, 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 blah. The engine was a port of an engine called Dimitri's engine that was written in C. It's very interesting to build such a complex thing as a game engine, such low language without any safety guarantees. Got it. So this guy is Mr. Dimas. He was able to port the engine to it in less than a year. Stability has improved dramatically since 2019. No more random crashes. Well, also since porting it. Performance was at the same or better levels. Time was invested in learning new language was paid off. Okay, great. Development speed does not degrade over time as it was in C. It is very easy to manage a growing project. Great. I'm glad for you, Mr. Dimas. I'm really happy. Or maybe Dimas. Don't know. Safety protection from memory safety related bugs. I love that. Logic errors still happen, but random crashes due to memory unsafety is very happy. Architectural design. The typical callback hell that is possible to do in many other languages is very tedious to implement in Rust. So don't do that. It is possible, but it requires a lot of manual work, which tells you that you're doing it wrong. Okay. Nobody's in chat. I hope my stream's working. Nobody's been in chat the whole time. Okay. Game engines are usually... did I finish it? Yeah. Hello. Thank you for lurking. I'm going on. I am a champ. Yay, thank you. I'm glad my stream's working too. That's good. Okay. Game engines are usually built using system-level programming languages. Great. Like C#, but peak performance levels, fyrox is not an exception. One of its design goals is to provide high levels of performance by default, leaving an opportunity for adding custom solutions for performance critical places. I will have one of those. Another very important part of it is that the engine should be friendly to newcomers. That's ideal. Great. Battle-tested concepts, not that I am aware of them. On the other hand, it can still be extended with anything you need. It tries to be good for veterans of the game industry as it is for newcomers. Great. fyrox has large projects built on it, which helps with understanding the real needs of a general purpose. That is great. It helps reveal weak spots in the design and fix them. I agree. Okay, that's things that I didn't really need to know, but it does give me confidence. Confidence is good. I like confidence. Frequently asked questions. Okay. Uses OpenGL. Okay. I wonder if they'll support WebGPU eventually. But OpenGL is good. Why not use alternatives now? There's no need for it. It works great. Okay, well, great. Current focus is on adding features that are missing as well as improving existing features when needed. If you have some specific demands, you can implement your own graphics server with the graphics API you want. See the chapter about that, and I don't care. That's great. Is the engine ECS? No, we've been over this. Use the right tool for the job. Don't use a microscope to hammer nails. That's okay, great. What kind of games can I make using fyrox? Any kind of game, except games that should be in ECS. In general, it depends on your game development experience. If I don't need the editor, you can ignore the editor and just use the framework. See the chapter about that. I would like to use the editor. Okay. This section of the book, yes, basics of the engine. You'll learn how to create a project, use plugins, scripts, assets in the editor. fyrox is a modern engine with its own scene editor that helps you to edit game worlds, manage assets, and much more. By the end, this section, you will have learned how to manage game and engine entities, understand how they are structured, and have basic knowledge of data management in the engine. Okay. The next chapter will guide you through the major setup of the game, creating a game project using the special project generator tool. They have a project generator tool. That's good. Actually, it might not apply to me. I don't know if my project is very similar to the projects that they're trying to make, but okay. Fyrox is a modern game engine with its own scene editor, editing game worlds, managing assets, and much more. Editing game worlds is the understatement of the century for what I am doing. But unfortunately, it's not the developer that I want to have edit the game worlds. It's the player. So you will have learned how to manage game and engine entities, understand how they're structured, and have basic data management in the engine. Okay, moving on. It's a compiled game engine. I kind of knew that. Compiled to native code before it can be run. This fact requires a specific project structure which is generated when you're making a new project. Great. A few Rust crates, game editor executors for each platform. Great. Every fyrox game is just a plugin for both the engine and the editor crates. That makes pretty good sense. This approach allows the game to be run from the editor and enabling, as it like a dynamic library? Don't know. Enables editing of the game entities from within it, sure, or just run the game without the editor, since not every game needs an editor. The chapter will cover how to install the engine with its platform-specific dependencies. I kind of wonder whether I'm really going to need the editor at the end of the day anyway. I might use it to set up, like, hi, Creator Mods. Yo, what's up? What are you working on? I'm making... It's going to be a bit before you see anything interesting. You're right. Today, I am working on figuring out how the heck fyrox works, which is a game engine. What am I working on? I'm going to be honest. I spent a while talking about that already, but I will go back. So there's a bunch of fantasy map generators. And I like them, and they are good, and they are feature full, and I don't know if I'll ever be able to provide the number of features they have. The main problem that they have is I'll do a new map a couple times until I get one that's a good representation. So if I pop this map on the globe, it has a seam down the side because Asgars, as brilliant as it is, generates stuff on a rectangle, does not generate it on the globe. And some map generators generate maps that are that don't have a seam, going side to side, but they still all pinch at the top. I've only found one blog post of anyone who is attempting to write write a map generator with spherical coordinates, which if you do it, if you generate your continents, etc., with points distributed on a sphere rather than points distributed on a rectangle, you don't get this pinching at the poles. If you distribute them evenly in the poles, you don't get the pinching, and the pinching annoys me. So, yeah, Laurel, this particular project is the coming together of very specific things that I have nerded out about over time. I would say that there are probably a lot of people who wouldn't, people who really know one part of what I'm talking about wouldn't necessarily be in the right world to know the other parts of what I'm talking about. We're combining areas about like world generation, which, I've read a bunch of blog posts about people doing continental shift and like drawing out the continents where the continents are hitting each other. You're putting mountains, and where they're splitting, you're not. Some of them end up as underwater, and some of them end up as land masses, and there's all these algorithms about that. And then taking all of these little weirdly shaped tiles all over the place. There was a blog post that everyone else seems to cite who makes a map. Somebody was like, hey, if you make your map out of these weirdly shaped objects, here's how you work with them and still have all the code make sense. So they detailed how to make all the code make sense when you make your map out of a bunch of weird shapes instead of squares. But they were like, when you make the whole map, everything being squiggly looks cooler than everything being aligned to a grid. So everything's based on that, and then they just pick which masses of the squiggly shape should be which biome. And I have no idea how Asgar's decides its politics. The politics part of their map is something I've not looked at a lot. There's the political map, there's the religions map, there's the cultural map. I'm guessing those three things all have pretty similar generation strategies. They just overlap in different ways. Provinces, probably related to those things. Height map, I'm really invested in. I really like the idea that I could render a globe that has accurate height offset. Like I'd just generate an image of the planet with the mountains actually sticking off. I want to see the mountains stick off. In fact, if I go to globe, I might be able to see the mountains stick off. I don't know. I don't think Asgar's made the mountains actually stick up. Oh, I think I can do 3D scene. They did it here. So, we just got to browser limitationsville. I'm in a fork of Firefox that it doesn't matter. Anyway. This is awesome. God, I like these generators. But anyway, none of them do quite what I want, which is I want them to not pinch at the poles, because I showed this right at the beginning of the stream, but I'll show it again. I have this way to make, let me make it just be me. Okay. I have this way that I came up with to for any arbitrary map. Obviously this is Earth. Generate a like paper object that I can print out and like glue together. I would love to be able to do that with a fantasy globe of a map of my own design, and then be able to tell my players like, hey, you're here. The bad guy's from here, I would love to be able to hand my players a physical globe and have them be like, this is the world we're playing on. I understand now. That would be wild. And it needs to not have all the pinching at the top because, gross. Okay. Asgar's is fine, actually, as long as you keep clicking new map until you generate one that doesn't touch the edges. If you get one that doesn't touch the edges, then it just takes up some part of the globe and you're totally fine. But some part of me is just like, that ain't it, Chief. That's not the ceiling on what we're doing here. Yeah, DM side quest. That's damn straight. I've probably put more hours into figuring out how to do this project than actually running games. That might not be true, but it could be true, and that's the kicker. Okay, so that's our summary. And then I will also say something I mentioned earlier, but I don't think either of you are here yet, which is when I decided that I wanted to do the coordinates on the sphere, I decided also that since fantasy authors, DMs or actual book authors or whatever might want their world to not always be on a planet, on a globe, that I would allow weird shapes. So people can upload their own mesh. They could upload this double donut thing, or whatever this is. This would be a very cool planet to play on, I think. And the reason I decided that is because I knew if I programmed that I may want that feature eventually. and then it would be easier to decide that now. If I program this whole thing based on a sphere, I know that the way I would do it on a sphere is simpler than the way I would program it to do this. And it will be harder to overhaul the whole thing later if I want to then be able to generate worlds that are shaped like a dragon, shaped like a horse, shaped like the Statue of David, or the Buddha, or a rocker arm, or a fan disc, whatever. You get it. I'm going to have a limitation on the curvature. Here's what I really want. So when you're zoomed out, you can see the whole planet. I want to be able to have you pick a point on your object to zoom in on and have it like pan the camera through the clouds so everything gets cloudy for a second as you're zooming way into the planet. And then it reveals kind of a whole other view of this where the world is flat, because when you zoom in on anything like this, it's going to be flat. And what that does require is that there's no sharp edges on your model. So I'm also going to have to figure out, like this fan disc or rocker arm, I would be requiring them to add, make these sharp corners kind of more curvy. I would round those over. I would love to have a button in there that says, hey, we're going to have to round your corners for you because you did not do it, and just have the game do it for you. So that would be neat, but that's math that I don't entirely know how to do yet, but it's probably a solved problem by other people. I just have to find who solved it. Yeah. So here's what I'm doing now. I need to be able to, like, first things first, take an object like this that's a file, upload it into my game. And I need to be able to do that when the game's running, not when the game engine's running, because the game engine definitely can do that already. I need to be able to do that as the player of the game, not the dev. So yeah, rewinding way back. That's like the vision. We're on day 1 of touching code, and I haven't touched code yet, so we're gonna get there. Okay. Before using the engine, make sure all the platform-specific dependencies are installed. If using Windows, no additional dependencies are required other than the latest Rust installed with the appropriate toolchain for your platform. Let me just do a real quick. Rust update. Do either of you have code experience / Rust experience? Rust 1.94.1. That's awesome. Nope, but you'd like to one day. Cool beans. Well, one day when you do, there's a tool called Rust Up that is the recommended way to visual novel with gameplay. You should look into Python RenPy. I'll type it in. RenPy is a game developer who made a Python program that has some issues, in my opinion, but with gameplay. I don't know what the limitations of RenPy are, but if you wanted to do just a visual novel, RenPy would be really worth looking into. Oh my gosh, I left myself on my screen. I didn't put my camera back. We're back, baby. Visual novel with gameplay sounds compelling, and would love to know what that's gonna. If it's gameplay where it's still just 2D and you're like clicking elements on the screen, RenPy can totally handle that. If you're talking about switching to like 3D gameplay where you're like running around in a world, or even 2D gameplay where you're running around in a world. I'm not sure NPy can do like animations at that level. It can do like one-off pre-coordinated, like activating an animation for the one action you've chosen, like choosing actions one at a time. And you could push the limits of it if you really knew what you were doing, but because you are, at the end of the day, still programming in Python, you can just take control. But yep, anyway, that's my tip. But Rust is not what I would program a visual novel in. It's one thing to look to Rust to is really high efficiency, and there's a trade-off between efficiency and usability in programming languages. So Python is just lovely to type. Python, when you start typing Python, you're like, wow, everything that I type it looks like it's verbalizing the actual thing you want to do. Like it looks almost like plain English telling you what you're going to make happen. And there's no other things that you have to like. Python starts with a support structure for you to handle all the complexities of running a computer program, and then all you have to write is the exact thing you want to do. But that comes with the disadvantage of Python might be doing a lot more than you would have to do if you had known in advance which structures you would need and how you would need them to be. And so if you want to remove a lot of that bloat for something that moves really fast, for a visual novel where you click and then there's like a couple seconds before you click again, Python has plenty of milliseconds to do all the calculations it needs to between each of the different clicks. It's not like your in fact, if I just open this, even just like rendering one of these objects and like rotating around it, that's calculating like every single triangle in the object and rotating it and calculating how the light bounces off of it, which is like you're calculating this line, you're calculating how it hits the triangle, what angle it bounces off at, how that angle hits the camera, whether that triangle is shiny or not shiny or whatever, what color it is. You're rendering a lot of stuff, whereas in something like RenPy, it just has to take an image straight out of memory and put it on the screen. And maybe like layer different images over each other and animate one that's like a series of images. Yeah, that's why game models are using triangles. I would say game models often use a combination of squares and triangles. I'll show you why. So as a game artist, you would be seeing. Let me take this down. Something like, picture a more complex shape, but that has cubes across it like this, or squares across it like this. There's a big advantage to this, which is that if you identify these loops, you can actually move. You can deform your object along those loops really easily and rely on the mesh kind of staying the same. Like staying correct, right? You take one of these loops, and I could take everything to the left of the loop. And, I could rotate it. Anywhere there's one of these loops, you kind of get a lot of flexibility in animating a 3D model. So you would definitely have loops around joints, loops around elbow, loops around shoulders. a lot of loops around your lips, a lot of loops right around your eyes and your eyebrows and your ears if you're wiggling your ears, like neck loops. What you really want is multiple loops, so that you can take this stretch that happens along one loop and you really want to be able to spread that out among multiple loops. I'm doing it wrong right now, but I think you get the idea. You want a bunch of loops here to kind of like be able to spread this out so it's not flat like this. Working on the topology now and still struggling with those loops being clean. There's something called retopology, which is very cool. Which is, so if you sculpt something that you really like, in fact, I'm going to activate dynamic topology. And it's going to make just an absolute mess of my loops. Do you use Blender? You're learning. So in Blender, there's two main ways to let to make like the object be exactly the shape you want. Supposing you're sculpting, I would say there's a tree. You can if your object's going to be super geometric, you can like never go into sculpt mode if you want, and sorry, give me a second. X only edges and faces. Okay. So if your object is super geometric, you could never go into the sculpting mode, and you could stay out here. I could put a bevel here. Is that how that works? You know, bunch of stuff I could do. That's still pretty geometric, but if you want anything like this, you're going to go into sculpting, and there's two ways to do your initial model shape. One is to hit sculpting and allow dynamic topology. And that's just going to change your mesh however it wants to as it fleshes it out. Let me see if I could turn this into something real. Let's make it be like a bowl with a crooked horn. Oops. Yeah. And there's a bunch of settings you're going to want to learn to play with, but this suddenly is an art stream. I'm not really doing this the smart way to do this. I'll do it the smart way to do it so you know what that looks like. Okay. If I really want to draw a bowl here, I would want to be adding shapes to this. So let's add a cylinder. I would want to block out the shape. So okay, and let's do this. Okay, and then programming is art, especially the kind of shit that I'm doing. But let's do union that. So, and then I'm going through to each of these objects I made, and I'm unioning them to that original object I was making. We got cylinder, we've got icospheres 1 through 4, or 0 through 4. So 0, this can be, well, whatever, it doesn't actually matter which one it is. As long as I get all. Great. I'm going to apply all of those, and then I'm going to delete the other things. Okay. Here's my new object. It is horrendous, but it is at least all one object. There's no longer anymore like if I go inside this thing, the holes have been cut out. These are all perfectly cut and like melded with each other. So if I go into sculpting and I turn back on Dentopo, which keeps turning off for whatever frickin' reason. I may also want to retopologize it. Nope, it's just doing it. We're good. So with dynamic topology, I can just start to work with this shape exactly the way it is. And there's a whole bunch of sculpting tools over here. At the moment, I'm just using the default draw tool and sometimes holding shift to switch to the smooth tool, just to get this be the way that I want it. Okay, so that's enough of that. I want to quick talk about retopology and then get out of here. Get back to what I was doing. Bam, bam. Okay, here's how retopology works. Let me make this snout look more snout-like before we try to topologize anything. We'll give him eyebrows. Okay, here's how retopology goes. Oh gosh, retopology. Okay. It's not like the most trivial task. There are tools that like attempt to do it automatically, but it is a pain in the ass. So here's how it works. I'm just going to start with a plane. And you put it up by your guy in the spot you're going to work on. And let's just work on his face, because that's an easy one that, like, it's really obvious where the loops go. You have to put the loops around the eyes and around the lips and stuff. So, okay, here's what you do. You apply a modifier to this, and I forget what it is. I think it's deform. It's like shrink wrap. We want to shrink wrap grade on the surface of the target. And it's now moving all the points of that plane onto the surface of the guy. And we can, just to help out, say this guy should render in front of other things. So now we go into edit mode. We're doing that manual style of per point editing that I was talking about earlier, not wanting to do. Oh, and I should make that modifier visible in editing. It should display as if it's just there. Okay. I can select an edge and I can extend, and I can just keep extending these points. If this were a symmetric model, I would have this butterfly symmetry thing enabled. But I can extend, I can move individual points around. I think you want a seam down the middle. I don't think you want a stripe down the middle. So there's my seam down the middle. And then I can actually if you select one and then control and then another, I can extend all of them at once and kind of make the plane that way. And you kind of want these to be pretty evenly distributed around your guy. From this angle, I can kind of see that the guy's eyebrows are sticking up out over they're sticking out over my mesh. So I'm actually going to hit Control R to split this edge here and just kind of try and absorb that a bit. This one eyebrow is giving me more trouble than the other, so I'm actually going to put more geometry here. Yeah, and then, so that's most of what you need to know for retopology, except that every once in a while you'll have a place where instead of 4 lines coming together, 5 lines will come together. And if you have to, sometimes you'll have a triangle. I prefer to avoid triangles at all costs and only ever solve weird shapes, because you can't extend a square grid over a whole object. It doesn't happen. If I, let's do this. Wow, that's real bad. I did not work very hard on making this bulb be anything remotely workable before I launched into retopology, but boy, it really doesn't want to be anywhere here. That's really weird. I've never had it act like this before, but I've also never done so bad a model before, so and tried to retopologize it. So if basically what I would do is I would get down to a point where I know I want a loop, and I would just extend these out in the direction of the loop. And I would work the loop all the way around. And what you want is to establish your major loops around the object. Doop, doop. And then you can close that up at the end with a bridge. But you get it. In fact, you said you get it. Yeah. You put the loops everywhere where it's important for it to be a loop, and then you just fill in everywhere else. Like this step that I did at the beginning where I filled in a big swath of land. That's not really how you start. But I have a great photo of it on my website. Here. So this is a bear that I was retopologizing. That's what it ends up looking like. And you can see the edge loops right around the eyes, right? You can see that I was kind of trying to have loops around the snout. There's loops that, match along the edge of the lips. You can see that the lips get a lot of mobility there. Anyway, you get it. Back to the regularly scheduled program. Yeah, you should just Google retopologized cat, retopologized alien, whatever it is. There's cool stuff. Okay. Do I need, was there any, no, this I opened entirely to show you that. This was open entirely to distribute the points on the sphere. Yeah, no problem. This is, that's going to stay open because that's my nodes. That's fyrox, that's fyrox. And this is where I was. Great. Okay. On Linux, fyrox needs that stuff. X developed from the project. That's awesome. Okay. The when I use Linux, I'm using Nix OS, so it's very cool to me that fyrox has like a special setup that just makes Nix OS work perfectly. Project Manager is pretty intuitive. Allows you to manage multiple projects made with the engine all at once. It allows you to create a new project or import an existing one, run the project or edit it in the editor, or upgrade the project to a selected version of the engine. Whoa! That's interesting. Okay, well, anyway, moving on. I only need to use one version at a time. But you can have multiple projects that use different versions of fyrox. That's wild. Okay. Many more options. If you want to learn more about the manager, read the chapter on it. Thank you, I will not. Download the project manager. Done. Then click the plus create button. Okay. Yeah, that's not high stakes. I can do that. Project manager, create a new directory for the project. The following structure. Okay, so I already have a folder for this project, which I've called Glorbe. And I think since this project is in a really questionable place right now, I will section off the fyrox part of the project into its own folder within there. So let's go ahead and just do that first. Create plus create. Can I type up here? Oh, here, E projects, Glorbe, open, name, fyrox, Glorbe. Style is 3D, that's great. Version control is none because I'm already using Git. I have Git enabled on the parent directory. Maybe I should say Git, and maybe it'll automatically detect that if it's smart. Let's find out if it did that right. fyrox glorbe. Nope, it has its own Git. It will not be doing that thing. Let's move the Git ignore out of here. I think that's probably sufficient. Okay. I hope it doesn't have anything that it specifically... I hope it doesn't have any Git tools that rely on it being the Git root. Gotta go. This has been very motivating. Even though you didn't understand it, thanks for making time and effort to show me the retopo. I'll check it out and try it for myself. I'm very interested in your project. We'll definitely try to check in on again. Good luck and drink water. Oh, I have water. Thank you for reminding me. Okay, wait, Laurel. If you want to keep in touch about that. The place where I post about this is... Nope. Do I have to sign in first? Oop, don't look at my email. Here. Leave Steve. This is where I posted today that I would be doing this. And I also post a bunch of other stuff on there, and I repost other people's stuff that I think is worth looking at. So, you know. If you feel like getting on Blue Sky, that's where to find me. Boy, people have been doing a bunch of cool crap on here. Let's see what stuff I liked. I'm gonna drink water now. Thank you. I also grabbed snacks in case I got hungry while I was streaming. What a smart guy that I was. Yeah, this is cool. Somebody was talking about how it's really easy to pause stuff in Godot because you just deactivate a whole length of a tree, which not every other game engine is based on a tree the same way Godot is. Yeah. There's cool stuff out here. I was working on a dice simulator in Rust before. That would not be to say a physics simulator of dice. This was just a simulator of... oh, this is not my dice thing. This is a whole other thing. This is too nerdy to talk about right now. Oh yeah, I complained about AI. Blah, 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 blah. I complained about a really specific and sensible thing about AI, not AI as a whole. AI is cool. It's just surrounded by a bunch of societal bogus stuff. Okay, that's enough of that. This is where to look if you ever want back. I need a moment. Okay, bet. Mic check. Okay, great. I'm back. It is building the editor. Let's let it build the editor while I keep looking. So, great. Game is my game code. That's the important part. Assets are nested in the data folder. Editor can be deleted later. Entry point is the executor, which I don't know how that could possibly not be needed. Based on where you're putting it. Well, I'm going to leave all of those, actually. Very cool. Very cool. Platform-specific dependencies. It can compile to Mac OS, and it can compile with a CLI export, which means that I can use GitHub integrations to compile it for Mac OS and see how that goes. It's really exciting. Yeah, none of this actually matters. Extremely cool. Extremely cool. That's a later problem. Tomorrow problem. Game dynamic library. Special bridge for native code. Hot reloading functionality can be... No, we will be hot reloading. Thank you. To run the project, select the new project in the list and click Edit button to run the editor. Or to run a game without the editor. I think I did that. Oh yeah, oh, I did that. Learn about the project manager here. You already linked to that, man. I already ignored that link. I'm not going to read it now. Your project needs to be compiled from scratch before it can run. It may take some time. Usually it takes up to 10 minutes, depending on the cores of your CPU. Next runs of the editor will only compile your game, which takes a few seconds. Anyway, after some time, you should see the editor window. I did. I saw that. cut down iteration times, you may want to use a powerful yet dangerous tool called native code hot reloading. To cut down iteration times, you may want to use a powerful yet dangerous tool called native code hot reloading. Learn more about it in this chapter. Okay, if you don't need the editor, don't use it. You can still compile your game to a desired platform, even the project manager and the projects it generates. Aren't mandatory at all. Okay. So far, I'm still looking to understand what to use the editor for. If you want to manually initialize the engine without all these fancy bells and whistles, read that chapter. This book is written in assumption that you're using the engine in the recommended way, and all non-standard usage may result in unexpected behavior. Okay. The recommended approach does the heavy lifting for you. I like not lifting heavily when I don't have to. Any object-specific game logic should be added using scripts. A script is a container for data and code that will be executed by the game engine. Read that. Now see that chapter. I am interested in scripting/scripting. We're going to open that new tab. And we no longer need this tab. We'll come back to that. Okay. Good luck and drink water. I'll drink more water in a minute. Okay, I'm going to finish chapter 3 before I... Yep. Installation. This section relies on fyrox template. I'm trying to figure out what they're talking about generating and whether I care. Oh, that's still to get to the same result. Okay. Yeah, okay. The engine can also be updated manually. The engine can also be updated manually. I no, none of that. Do not care. Okay. We're at 3.2. I need to finish 3.9. Good luck, I got this. Thank you, Laurel. Laurel. Okay, whatever. Fire oxide overview. There goes my plug. Okay. fyrox editor. Native editor. One purpose, integrated game development environment that helps you build your game from start to finish with relatively no effort. You'll be spending a lot of time in the editor, so you should get familiar with it and learn if you're using it at all. You should get familiar with it and learn how to use its basic functionalities. This chapter will guide you through the basics. Advanced topics will be covered in the respective chapters. When you open the editor for the first time, you may be confused by the number of windows, buttons, lists, etc. you'll be presented with. Each window serves a different purpose, but all of them work together to help you make your game. Let's take a look at a screenshot of the editor and learn what each part of it is responsible for. Please note that this can change over time because development is quite fast and images can easily become outdated. Yeah, I get it. Okay, this is what mine looks like. It's got an inspector. It's got a scene preview, world viewer, asset browser, command stack. That's interesting. Message log. Okay, there are warnings. Code has triggered possible performance issues. Vertex shader is being recompiled based on OpenGL's state. Okay. Audio context. I don't have any audio in my game yet. Okay. Okay. We're gonna leave that. World viewer. Did I have that? World viewer. Yes, that's my tree. Shows every object in the scene and their relationships, allows inspecting and editing the contents of the scene in a hierarchical form. Scene preview. There's the scene with debug, info and various editor-specific objects, gizmos, entity icons, etc. Allows you to select, move, rotate, scale, delete, etc. various entities. The toolbar on its left side shows available context dependent. Okay. Inspector allows me to modify various properties of the selected object. Inspector. That one. Yeah, okay. Message log I got. Nav mesh panel. Where's that? I see nothing called nav mesh panel. Ah, because it's not in the screenshot. Command stack. Am I crazy? Nav mesh panel. I don't think I'm crazy. Nav mesh panel. Nav mesh panel. Nav mesh panel. Whatever. Nav mesh allows you to create, delete, and edit navigational meshes. Command stack displays your most recent actions and allows you to undo or redo their changes. Displays your most recent actions and allows you to undo or redo their changes. Command stack displays your most command stack. Oh, well, that's cool. Great. Allows you to inspect. Asset browser inspects the assets and to instantiate resources in the scene, among other things. Audio context allows me to edit the settings of the scene's sound context, like global volume, available audio buses, effects, etc. Fair enough. Okay. Creating or loading a scene. Scene is a container for game entities. You can create and edit one scene at a time. You must have a scene loaded to begin working with the editor. To create a scene, go to File, New Scene. To load an existing game, go to File, Load, and select the desired scene through the file browser. To load an existing scene, go to File, Load, and Okay, great. Good luck, I drink water. I'll drink more. A scene can contain various game entities. I'm going to make sure real quick that my YouTube chat's working. Okay, bet. It's working. Nobody must be saying stuff. It is working. Okay. Populating a scene. These are the same. Create in the menu and select the desired entity. Right-click on a game entity. Select the desired of the created child submenu. It feels like those are not equivalent because one of those feels like it will be a child. But whatever. Complex objects usually made in 3D software can be saved in various formats. Fyrox loves FBX. Drag the one you want, drop it on the scene preview. While dragging it, you'll also see a preview of the object. Let's see if I can just drop an OBJ. Let's see if it'll just take it. Don't know what MTL is. Oh, material. It's a material. Yeah, no, does not like it. Does not like it. Okay. Well, that doesn't matter because I'm not asking fyrox to import it. I'm asking me to import it. So we're gonna ignore that. Other scenes made in the editor will be represented as RGS files. You can make a scene with a few objects in it with some scripts and reuse them within the other scenes. Such scenes are called prefabs, the ones that you reuse. Okay. To save your work, file, save. If you're saving a new scene, the editor will ask you to specify a file name and a path where the scene will be saved. Scenes loaded from a file will be automatically saved to the path they were loaded from. I want to look back here because it told me about this tree. Game is the game code. Data is where the assets are. I'm going to guess data is where, yeah, your scene goes in data. Great. Great. Scenes go in data. You can undo and redo stuff. Z and Y. Control keys. Oh, let me memorize some keyboard shortcuts real quick. What? What? Okay, WASD. Move camera forward, backward, left, right. Okay. Wow. Okay. Shift right click. Okay. What kind of light are you? You're a spotlight. What kind of cat are you? What kind of cat are you? Tell me true. What kind of cat are you? Okay. Okay. Some of this seems wrong because they're right clicking. Oh, click and hold right mouse button to enable the movement controls. Gross. Okay. This looks really cool and important. You can change the hierarchy of nodes in the editor using a simple drag and drop functionality in the world viewer. Drag a node onto some other node and it'll be a child. Building blocks or scene nodes. The engine offers various types of building blocks for your scene. Each such block is called, that should be a period. Each such block is called a scene node. You can just edit that. They were pretty cool for putting that in. Scene node. Base. Okay, everything is made of a base node. I'm ready to get into it. I might have to come back to this. I don't care about all this. Pile map, great. Sound. Great. An audio receiver that captures the sound at a particular point in your scene and sends it to an audio context for processing and outputting to an audio playback device. Okay, that's cool. Container for multiple animations. You can play animations made in the animation editor and supply animation poses to the respective scene nodes. You can play animations made container for multiple animations. It can play animations made in the animation editor and animation poses to the respective scene nodes. Okay. Animation blending state machine, a state machine that, yes! Each state is backed by one or more animation playing or blending nodes. See, it has a whole chapter. Great. I don't need that for this, but great. Every node can be created in the editor. Through create on the main menu or through add child after right-clicking on a game entity, or programmatically via their respective node builder. Each node can be created either in the editor or programmatically via their respective node builder. These scene nodes allow you to build almost any kind of game. It is also possible to create your own types of nodes, which is an advanced topic which is covered in a future chapter. Okay, I don't know that I need my own type of node. A graph describes your scene in a very natural way, allowing you to think in terms of relative and absolute coordinates when working with scene nodes. Yeah, great. I love that. 2 transforms. Yeah, sure. Yep. Scene node can have 0 or more scripts assigned to it to execute some logic associated with the node. Scripting is a separate large topic, and it is described in the respective chapter. Okay, that's that same chapter that Chapter 4. I'm going to need Chapter 4, I think. I do believe. Okay. Okay. The engine offers a set of assets that should cover all your needs. Models are a set of objects. They can be simple 3D models or complex scenes with lots of objects and possibly other model instances. fyrox supports a number main formats, FBX and GLTF, which can be used to import 3D models. RGS, which are scenes made in fyrox add. They can be used as hierarchical prefabs. Textures are images used to add graphical detail. PNG, JPEG, bitmap. Compressed textures in DDS are also supported. I've never heard of DDS. I will hear of DDS now. DirectX, okay. Direct draw surfaces for DirectX applications. It's for Windows. Got it. Oh, now widely supported. See, that's compelling. The format provides a standardized way to package texture data with necessary metadata for GPU consumption, ensuring optimal performance and compatibility across different hardware platforms. It's a wrapper around various texture compression formats like the block compression family, which provide efficient hardware-accelerated compression for different texture types. The design allows developers to store textures in a format that can be directly loaded by the GPU without additional processing, minimizing memory bandwidth and maximizing rendering performance. Comprehensive feature spread, widespread adoption, 2D textures to complex cube maps and volume textures. Okay, well, cool. How do you make one? Interesting. It's good for LOD. Level of detail rendering. How to make it? How do you 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 make it? This is from 2009. Wow. Great. Yep, that's... So this is old. Wild. Okay, I think I'm about to go to a website called poopinmymouth.com, even though I don't want to. I use the GIMP DDS plugin to output DDS files. And textures made with no compression don't seem to work. But 1, 3, and 5 all appear to work correctly. Okay, so this person's using GIMP. One and 5 are the important ones. Oh, okay. 1 and 5 are the most universal and most flexible. Hmm. 4x4 square of pixels and saves only 2 of the 3 RGB channels for that square. For each square, it will alternate which channel it drops. What? 2 of the 3 RGB channels for that square. 4x4. 2 for each 4x4 square. Alternates which channel it drops. Okay, alpha becomes 1 bit. That's great. That makes sense to me. Four to 1 ratio of compression, not as small as DXT1, which has an 8 to 1. Little RGB difference, does have an 8-bit interpolated alpha channel. Good for alpha. Doesn't have the severe banding. Because of the lesser compression, there are less artifacts on the normal map. This would be useful for organic, highly noisy maps, but not clean, sharp-edged one where an uncompressed target or even PNG may be the best choice. Okay. DXT5 will eliminate much of your fine detail within a normal map. Yeah. Okay, good to know. Good to know. Good to know. Good to know. Done with that. Now we know about DDS. Okay. Sound buffers, data buffers for sound sources. Fyrox supports a number of sound formats such as WAV, MP3 formats. Curves are parametric curves. They're used to create complex functions for numeric parameters. I'm gonna have to figure out what that is talking about. Hard-related impulse response. Yeah, I don't know what that is. Tree type font, open type font. Materials, shaders, great. A set of named variables that can be used to alternate. A set of named variables that can be used to alternate the look of widgets all at once. A set of descriptions for tiles used in tile apps. Okay. Animation tracks container, a special container for shared data of animations. Okay. It's also possible to create custom assets. Okay. Many more very specific asset types. Okay. Asset management is performed from the asset browser window within the editor. You can select an asset, preview it, and edit its import options. You select it down there. Edit it in the inspector. Yeah. The most interesting part here is the import sections under the previewer. It allows you to set asset-specific import options and apply them. Each asset has its own set of import options. See their respective asset page from the section above to learn what each import option is for. if they can be instantiated in scenes, you'll want to create direct instances from the models. This is done simply by dragging the model you want to instantiate it and dropping it on the scene preview. You'll see a preview of the model while you're dragging it. Far enough. Maximum number of asset instances is not limited by the engine, but it is by the memory. Maximum number of asset instances is not limited by the engine. Yeah. You gotta have a good computer. The engine does try to reuse data across instances as much as possible. Thank you for optimize for me. You can also instantiate assets dynamically from your code. Here is an example of that for a model. This is going to be useful for later. Async function, instantiate model. Borrowing a path to a model. That's the resource manager. We're going to modify that scene. We're going to give you a node handle back. Load the model first. Alternatively, you can store the resource handle somewhere and use the handle for instantiation. Load them all first. Load them all. Okay. You can store the resource handle somewhere and use it for instantiation. Okay, model.instantiate scene is going to return a handle. I'll have to figure that out later. But yeah, this is very useful with prefabs that you want to instantiate and a scene at runtime. Yeah, that. Usually there's no need to manually handle the loading of assets since you have the editor to help with that. Just create a scene with all the required assets. However, there are times when you may need to instantiate some asset dynamically, for example, about prefab. For these cases, you can use the resource manager request method with the appropriate types, such as model, texture, sound buffer, etc. I'm going crazy. It's time for me to not be streaming anymore. If you are watching, say goodbye in chat real quick so that I know that you were watching and that you know I'm leaving. Goodbye. I've been streaming for too long. Too long. Too long. I will say goodbye, big.